Good evening. This is a bonus lecture. I'm going to have, well, I have already covered blood and endocrine, all the material. And now I'm going to make this review lecture. So it's only a couple dozen slides, but I think I will go through, hit the high points, not everything, but hit some things. This may be helpful. If you've already studied, you're ready to go. So you listen to this like, I got it. And if it's all foreign to you, then you've got some studying to do. So it's gonna, you're gonna figure that out pretty quickly. So let's go ahead and talk about endocrine and blood. All right. I put this PowerPoint on Blackboard if any of you are interested in looking at it, but let's see. Actually, I'll see if I can save a copy with my annotations. All right, so next week, you'll have a practical. And then for the practical, just look at the labs, look at that diabetes lab. And again, you don't have to know all the numbers for the lab values, anything like that. But the big picture, what, some of the questions that I asked, what diabetes is. And then blood lab, there'll definitely be blood typing, hematocrit, just things we do in lab. And then endocrine, what you did online. So you need to recognize those 5 glands or so and the hormones that come from them and what they do. What you need to know for lecture 2. So practical, and then the lecture exam will be multiple choice, true, false. I'll give it out and I'll have questions from blood and endocrine chapter. So just to review, let's get our minds in endocrine and look at the hormones. And this gentleman here, there we go. I can draw pretty nicely. Probably, what hormone do you think he has an overabundance of? Yes. Growth hormone, indeed. And why probably? Probably a tumor of the pituitary gland, producing too much growth hormone, getting giganticism. And don't forget, if this happens not during childhood, but when you're an adult, it's called acromegaly. And then your face, your soft tissue, your tongue grows big. So it's a problem to have too much growth hormone. All right, so let's take a look at this woman. She jittery all the time, heat. So we're not talking about kind of change of life thing here, looking at that. So the idea would be looking at this, what hormone do you think is the issue? And is she making too much or too little? If you're jittery, too warm, yeah. You want to think thyroid hormone. So she has an overactive thyroid. And it could be Graves' disease, an autoimmune disease, or a tumor, either the thyroid or pituitary. You're producing too much thyroid hormone. Oh, what could you do? What would you do to help? Oh, you probably want to operate on the thyroid gland, remove some of it. You can give radioactive iodine, and it will go to the active cells in the thyroid, and it will destroy those cells. So that's what you need to do. And if you get rid of too much thyroid, then she would have hypothyroidism, and then you'd have to give pills, artificial thyroid hormone, to replace, because you need some, but she obviously has too much. Take a look at this guy. And I'm looking, I see, I don't know, right, that moon face, those striations in the skin. And I bet he's going to be hyperglycemic, too much sugar in his blood. Let's see, says an acne, muscle strength is decreased. Yeah. Oh, yes, here it is. So high sugar in the blood. What's going on? We're losing some muscle, protein in the skin, not making collagen correctly. Yeah, it is going to be Cushing's syndrome, which is an overabundance of cortisol. You're making too much adrenal cortex hormone cortisol, and it's going to keep you persistent stress conditions, high blood sugar. You're not making proteins because you're using amino acids to make sugar. And so you can't make protein very well, so bad skin, and you have high blood sugar because you're persistently, doing that. So if you look at detailed blood work, sure, the sugar, say we did a quick sugar, said, oh, it's high, something's going on there. And it could be diabetic, something like that. But hormone you expect to be high would be cortisol. Yep. And you could see it could be ACTH. ACTH is released from the pituitary, which is going to tell the adrenal gland to release cortisol. So it could be at several levels. And if you remember, I talked about ectopic tumors could be producing cortisol too. Tumors other places in the body. So it could be the adrenal gland is making too much cortisol, but it could be the pituitary that's making too much ACTH, and that's the hormone that stimulates that. All right, and it could be something in the brain, the hypothalamus, which is telling the pituitary to make too much ACTH. And there it is. If you do an MRI, you could see pituitary has a huge tumor on it. And lastly, for these case studies in endocrine, look at this x-ray and you see, oh, I showed you this one in lecture in class. And what we have is the bone is being eaten away too much. You look at the x-ray of the skull, you see these peppering, cavities in the skull. So what would make you break down bone too quickly? There's two hormones that are due with blood calcium levels, calcitonin and parathyroid hormone. And parathyroid hormone is going to increase your calcium levels, so it's going to break down bone. It's also going to make vitamin D be activated, so you absorb more, and it makes your kidneys not pee out as much. So those are the three things where you can influence calcium levels. All right, so some case studies so you guys get familiar. Just memorize all the hormones, the glands, what they do. And that's going to be a bulk of that part of the practical and that part of the exam, right? Just so you remember, endocrine glands, you can look at that introduction. It's where the glands secrete their chemicals into the bloodstream, all right? An exocrine gland goes out a duct somewhere. So saliva, or sebaceous glands making my hair oily, or glands in my stomach secreting acid through these ducts. So that's what we're talking about there. And the pancreas is both. It's both. Endocrine, it makes insulin and glucagon, and then exocrine, it makes pancreatic juice, which squirts into your food in the intestines. And then look back over how the difference between and the similarities. You may say to yourself that hormones are less specific, because the nervous system, the axon goes right to that muscle and it's going to stimulate it, right? But hormones, they're very particular chemicals, and you need a certain receptor on the cells. So hormones are thrown out. It's like that Facebook message. Everyone's got to listen to it, but only certain cells specifically are listening to it because they have those receptors. And hormones can be more long-term, a little bit slower. Nervous system is fast and very specific. Don't forget what pheromones are. That is, unlike hormones which stay in your body, pheromones go between individuals. All right, and a big part of this lecture was the big difference when you look at the chemistry of the hormones. You have steroids are fat, they're lipid-based. So you can see they have this cholesterol backbone. So steroid hormones, and these are estrogen, progesterone, and the adrenal ones, cortisol, aldosterone. Those are the main ones. The rest of them are non-steroid. They're proteins or peptides or something like that. And the deal is steroid hormones, since they're fatty, they go right through the membrane. They don't, because they dissolve in fat because they're fat. And then they'll go right into the nucleus where they will find some receptors, and then they will actually go right onto your DNA and activate genes or deactivate genes. So their influence is right into the brains of your cell. And they're going to turn on genes that will then be transcribed and translated and have an effect. Non-steroid, a few more steps here, but they can't go through the membrane because they're charged and they're big and they're hydrophobic. So they don't want to, hydrophobic? They are hydrophilic, I'm sorry. And so they don't want to go through that hydrophobic fatty membrane. So they're going to go onto receptors on the cell surface for the particular hormone. And then G proteins will turn on adenylate cyclase. And adenylate cyclase is going to take ATP and make CAMP. just takes off 2-phosphorus, makes a cyclic AMP, and CAMP is going to get excited these enzymes, and it's a cascade or a path that's going to go down till eventually it's going to make whatever that hormone is doing to that cell, whether it's going to make a product or break down something or make the cell move, or whatever it's going to do. The hormone, the effect it's going to have is going to go through the receptor on the cell surface. G proteins turned on, they make adenylate cyclase, make CAMP. This is most of the case. Most of the time this happens. And then the CAMP is going to make protein kinases are going to put phosphorus onto molecules to get them excited and turn them on and make usually make a product in the cell. All right. Prostaglandins, take a look at one slide on them. Just realize they're paracrine. They're made in the neighborhood, and they're made, have to do with often with pain and modulating other hormones effects, and aspirin brings them down. So look at that. And remember, hormones that you make in your body, they go in the bloodstream, and then they're broken down either by the kidneys or the liver, and then they're peed out, so that hormones have a half-life. They only last so long. And the half-life is, if the half-life is an hour, that means that in an hour, half of that will be gone. Another hour, another half will be gone, that kind of thing. So it's how long they last. And all these hormones you're going to see, they're not going to be absolutely stable. They're going to go up and down a little bit over some kind of a normal range. And it'll be negative feedback. You make a bunch of thyroid hormone, your metabolism gets high, and then that's going to shut off the thyroid hormone. If it excited it, you just continue until you blow up, right? So negative feedback is going to bring it down. Blood sugar, when it gets high, you secrete insulin, then it comes down, you secrete glucagon, it comes back up. So hormone levels have like standard levels, but they always are going, up and down a little bit over that. And then went through all the glands and started pituitary. That's the biggest one, all right? And the deal with the pituitary gland, if you remember, the anterior lobe is very dark, and it's making 6 different hormones. So the anterior is called the adenohypophysis, another name for pituitary. And then the posterior gland, it goes up into the brain even. The posterior gland, I'll talk about that first, the posterior lobe of the pituitary gland. The hormones are made up here, 2 hormones, oxytocin and ADH. And they're not produced in the posterior lobe. They're produced here in the hypothalamus, but they're released here where they'll go into the bloodstream. And oxytocin was fascinating. You get it when you hug someone. It's also in childbirth and letting milk out. I talked a lot about that. And then ADH is antidiuretic hormone. It's going to make you retain water and thus raise your blood pressure. It's called vasopressin too. Right? So it works on the kidneys, ADH, primarily to make you retain water. This anterior lobe, oh my God, you're going to make growth hormone, thyroid stimulating hormone. You're going to make ACTH, which is going to stimulate your adrenal cortex. You're going to make prolactin. Prolactin, you produce milk. 1, 2, 3, 4. And then the second 2 will be follicle stimulating hormone and then luteinizing hormone. Follicle stimulating is going to get your eggs going or sperm going. And then luteinizing peaks at ovulation. So just know that. Yeah. So all 6 of these. And know that these 6 hormones, they're made by the anterior lobe of the pituitary. But way up here in the hypothalamus, you produce releasing hormones that go into the bloodstream that travel down the blood into that anterior lobe and stimulate the cells to make the actual hormone. So in case you didn't notice, you think the pituitary gland's in charge, it's really your brain, the hypothalamus, that's controlling it. And in fact, 2 of the hormones are made in your brain, in that nervous lobe or posterior lobe. In the anterior lobe, they wouldn't do a damn thing until they get their signal from the boss in the brain, and those releasing hormones will tell them to release. All right, now I went through all these, so know what they do. I gave you just a brief outline there. All right, so pituitary, big one. All right, now thyroid gland sits here. And you should know the 2 hormones are T3 and T4. These are your thyroid hormones. And what do? They're going to increase your metabolism. You're going to burn sugar. It's going to make cells active and divide. And the thyroid gland right here is under influence of thyroid stimulating hormone from the pituitary. And so when it's stimulated, these cells are on the follicles. So know the histology of it is very unique. You have these follicles and this colloid substance in the middle called thyroglobulin is a pre-hormone. And then these follicle cells, when they're stimulated by thyroid stimulating hormone, they'll eat some of this and release thyroid hormones into the bloodstream. So thyroid gland under control of your pituitary, when it says jump, it makes thyroid hormone. It's going to get you active. And again, know what hyperthyroidism and hypothyroidism is. Too much or too little. Yeah. And then there's also cells in the nooks and crannies. You should also know one other thing in the thyroid gland, it's not related to this, is that you have these parafollicular cells in the nooks and crannies that secrete calcitonin. Oops. When your blood calcium levels are too high. And they're too high, you secrete calcitonin, and that's going to cause calcium to be laid down in bone. Pee it out. Don't absorb as much. And the parathyroids secrete parathyroid hormone, or parathormone. And these guys, all they do is they just monitor your calcium levels in your blood. When they drop, they're released. And remember, the three-pronged way that you increase your blood calcium levels, break down bone, make vitamin D active so you can absorb more, and tell your kidneys don't pee it out. That's going to raise your calcium levels. All right, your adrenals are the other big one after the pituitary. They have a lot going on. And so you need to know these three zones. Oops. There, 1, 2, 3. 3 zones in the cortex. And then the medulla, or the middle, is modified neurons that secrete adrenaline, also epinephrine. And you really make epinephrine and norepinephrine, or adrenaline, noradrenaline. And so you make them like 80-20%, and they have subtle differences. I want you to know that. But these are secreted when you need fight or flight, right? Your body's under stress, whether it's emotional or physical, and it's going to increase your blood sugar, make your pupils dilate, breathe faster, right? Yeah, cool. And then the 3 zones, know what hormone comes from these 3 zones. And it was salty, sweet sex, if you want to remember that. Aldosterone is salty, makes you retain salt, plus water. And then the middle fasciculata has cortisol. Talked a lot about cortisol, stress hormone. And then the reticularis, that inner zone, is going to make sex hormones. All right, so review the hyper and hypothyroidism. So look at Graves' disease and Hashimoto's disease. They're 2 autoimmune diseases. And then cortisol levels, you can have too much in Cushing's. You get that moon face, like I had in that early case study. And Addison is the opposite, where you don't have enough cortisol and you end up being low blood sugar and your skin turns darker. A couple cool things. Very rare, but we're talking about differences in cortisol levels. And Cushing's, you should know, it's more popular today, more common because we give a lot of steroid drugs, right? And then don't forget rickets is when you don't have enough vitamin D and your bones become bent and weak. And lastly, well, in terms of the big glands, is the pancreas. So the pancreas is huge. But again, most of it is exocrine. It's making juice that is squirted with digestive enzymes. But we care about the little islands. There's little islands in the pancreas that secrete those 2 hormones, right? Insulin and glucagon. And insulin is going to raise your blood sugar. Glucagon will lower it. So these things keep your blood sugar nice. Between meals, glucagon is released. After a big meal, insulin is released, if all's working well. But of course, I'll ask you a question about diabetes. No, type 1 is often called juvenile, where your pancreas doesn't make enough insulin. Type 2 is often developed later in life. And I showed you how obesity is often tied with type 2 diabetes. And that's where the cells become resistant to the insulin. Yeah, and so you have high blood sugar, which is dangerous. So either diabetes, high blood sugar is dangerous and cause blindness, all kinds of problems. And then some miscellaneous, talked about the pineal gland. You know the hormone is melatonin, and it regulates your day length, your circadian rhythms of when you wake up, when you sleep, your seasonal rhythms. And then the thymus, know that it's big as a child, and then it gets smaller as an adult. And it's important for, it's going to mature the T cells, the lymphocytes for immune system. All right. I'll take a little break here. So I quickly went through points that are going to be on the test. I mean, this is absolutely, I may have missed some things. Oh, I did miss some things, but that's the bulk of it. So hopefully you were following along, and if it's the first thing you saw, you'd be lost. I mean, probably you go too fast, but hopefully this is review. You get a bunch of it. If something was foreign, then you should definitely look that up. So, but these are the things that seem important to me. I threw into this kind of review PowerPoint. All right. Let's talk blood, and then we'll wrap it up here. So blood, of course, for lecture and lab, know that it's a connective tissue, which means it has cells. And you all know it has red blood cells, and know they're called erythrocytes. White blood cells, know they're called leukocytes. And then platelets, know they're called thrombocytes, because a thrombus is a clot. And then the matrix is plasma, mostly water, yellowish water. And then the fibers are hidden. The connective tissue has fibers, but that fibrinogen is going to be dissolved in here. You don't see it, but in clotting, it'll become fibrin, and you'll see this, the fibers. No, you have about 5 liters, but it depends on your hydration, your size, if you're pregnant, all these things. And of course, functions of blood. Make sure you can look at that. And know what a hematocrit is. If you didn't make one in lab yourself, you studied it. You just divide the part that is red blood cells by the whole blood, and that'll be your hematocrit. Should be about 45%. A lot of you in lab are 37-ish%. Women a little less than men. But it tells you how much of your blood is made up of red blood cells. And if it's low, if you have like 20% hematocrit, it means you're anemic. And then plasma. Well, this is whole blood. I'm sorry, whole blood. So you can see it's about not quite 50-50. It's about 45% called the formed elements. These are the cells and such, and cell fragments. And then the rest of it is the watery part, the plasma. Yep. And you can see there's about 5 million red blood cells per milliliter. You should know that. And you should know there's about 3,000 to 10,000 white blood cells. And then there's like 100 to 400,000 platelets. So just get those ballparks, right? And then of the white blood cells, of course, you guys have studied the 5 different types. I'll hit that in a minute. And then plasma, you can see, is 92% water, average, depends how hydrated you are. And then electrolytes, and then wastes, and nutrients, and vitamins, and hormones, gases, oxygen, carbon dioxide, the important ones, unless you're scuba diving. And then we'll talk about proteins in the blood. And realize that you guys make all of your red blood cells in your bone marrow. But early on, it was your liver and spleen in utero. And so this is bone marrow, and that's where you have stem cells. They are pluripotent, which means they become any kind of blood cell or platelet you want. Just depends on what signal they get. And so it's all these dark cells in here are going to be the stem cells and all the daughter cells that are made. And so realize the hormone is EPO, erythropoietin. That's going to tell you to make more red blood cells. And then thrombopoietin is going to tell you to make more platelets. Or white blood cells, it's called colony stimulating factors or interleukins. So these are the signals to the bone marrow on what to make. What do you want to make from these stem cells? And they're released into the blood, and they're released. Now, in terms of, let's talk about red blood cells. You need to make them, and you make millions, right, per second. So many you make. They need vitamin B12, folic acid, and iron. You need these things, particularly if there's deficiencies in those, you'll be anemic. So you need those to make it. And blood cells last about 120 days. They don't have a nucleus, so they can't repair themselves. And then they're broken down by macrophages, mostly in your spleen, but in your liver and bone marrow. They're broken down and recycled. And in the heme, the iron is recycled. You lose some of it, but a lot of it's recycled. And then know that biliverdin and bilirubin are pigments that are made from broken down blood cells, red blood cells. And these are put into your bile, and they'll go out in your digestion system. digestive system. But if they build up, if you have too much blood cell destruction or your liver is bad, you get jaundice, where you turn kind of yellowish, the whites of your eyes and your skin. All right. Yeah. There's a lot there. Red blood cells, again, they have no nucleus. By having that shape, they're about 28% more surface area. They're packed with hemoglobin to carry oxygen, and they're about 7.5 microns or micrometers. Yeah. And this hemoglobin, awesome, does this cooperative binding where once oxygen binds to one, it's more likely to bind to the others. Very, very cool. And it's got that iron in the middle of it, right, of your hemoglobin. Yeah. And by having the shape, it makes them flexible, and more surface area means more hemoglobin is near the surface, so it can get in oxygen from your lungs and release it in your tissues. All right. And don't forget, this is arterial and venous blood. Looks like brighter red and more bluish, depending on how oxygenated it is. There's some terms there. If you're cyanotic, you're blue, means you have low oxygen. You look like you have a lot of deoxyhemoglobin. No anemia can be not enough blood cells or not enough hemoglobin. You know the sickle cell, what's going on there, one gene mutation. Yep. And know what blood doping is. You can look at that. All right, the white blood cells, for the practical, I'll have you identify them. In the lecture, I'll ask you about them. But yeah, and if you remember which is the most common, it's naughty little monkeys eat bananas. So naughty is neutrophils the most common, basophils the rarest, less than 0.5%. Yeah. Yep, so the most common ones will be neutrophils and lymphocytes. This may be up to 70% of them. Yep, and then you notice these are granulocytes. They have granules in them. And these are agranulocytes. They don't. And your lymphocytes will be your T cells and B cells. These are ones that have memory, that make antibodies. Yeah. Monocytes turn into macrophages. Is the biggest of the white blood cells. Macrophages can eat lots of invaders, hundreds of invaders. So more, maybe sometimes more chronic diseases, they can spend a lot of time. And they're found everywhere in your body, macrophages. And of these, the neutrophils are the cavalry. They're stored in the bone marrow. There's just tons of them. And they come and they eat bacteria and they die and turn into pus. So they can't eat as much or as big a things as macrophages, but there's tons of them. And they'll go to the place they need to go. And then eosinophils, just know allergies, parasites, they're bright red. And basophils know the two chemicals they hold, heparin and histamine. And they're useful in infections and inflammatory response and getting the blood thin and the capillaries leaky to bring those mostly neutrophils to the area. All right, and then I showed you this. The term diapedesis means when white blood cells leave the bloodstream and go into the tissues. And they go there because they're getting signals from the lining of the vessels in the area. So if there is an infection or damage, it's going to make these cells put up these signals. And it's going to, histamine is going to make it leaky. And so these neutrophils that are just zooming through your blood will stop. They'll stick, and then they'll leave. And they'll come and they'll eat the bad guys. And this is the quick quiz. I don't spend a lot of time on this, but you can see a big monocyte. Here's a couple of neutrophils. I'll pause so you guys can take this quiz. Yep. Neutrophil. Now this will look at the size. Notice in comparison, it's 3 times the size. So it's a monocyte. This one's much smaller, right? And the nucleus is huge. Yeah, I paused for you. Lymphocyte. And that one, bright red, eosinophil. And if it was bright blue granules, it'd be basophil. All right, good job. All right, let's talk platelets. They're also known as thrombocytes. And a thrombus is a clot, a blood clot. You guys remember what it's called when a blood clot breaks off and it travels in your bloodstream? Then it's an embolus, or emboli, plural. And an embolus can also be fat or air or something else, but it's usually a clot that comes off. But platelets are fragments of these megakaryocytes, these big stem cells in the bone marrow, and they're just packed with chemicals for clotting is what they are. And they go to where there's a break and they will plug up the break and they will release chemicals. So without platelets, you won't clot and you'll bleed to death. Too many platelets, you'll clot too much and there will be clots and there will be issues. Now you can look at what's in plasma. You can see it's like 92% water. The gases. Bun is blood urea nitrogen. So these things, if it's high, it means your kidneys aren't getting rid of it. And no, you should have mostly sodium, chloride, calcium, magnesium, all these things. And then the proteins, I could ask you this. So realize, especially, this is really kind of very, very important here, okay? So albumin is the most common protein in your plasma, and it's for osmosis. I hope you guys get that. It's just filling up space in the blood so that water is sucked back in from the tissues. And if you don't have enough albumin in your blood, water will stay in the tissues. You'll have edema, this swelling. I showed you the starving, the belly swelling because they don't have enough protein, all right? And these proteins are made by the liver and they travel in the blood. And then fibrinogen is for blood coagulation. Fibrinogen turns into fibrin, okay? And then in terms of the globulin proteins, know that gamma globulins are antibodies. And we'll talk a lot about antibodies. And then the other ones, alpha and betas, they are for transporting things that don't dissolve in water. All right, hemostasis is blood stopping damage. And realize, very important, big three things. You want the blood vessel to constrict to prevent the leaks. This is an emergency. You got to break in the line. You want to clamp off if it can. Then immediately platelets go and make a plug. And then the chemicals from the platelets are going to make coagulation in a clot form, where out of the blue, out of this liquid plasma comes these fibers appear, because fibrinogen turns into fibrin. It makes a sticky net, which is going to trap red blood cells, trap more platelets, and it's going to wall over that leak in the tube. Yeah. And then intrinsic or extrinsic is how clotting starts. Extrinsic is from damaged tissue outside of the cell. Intrinsic can be from within the blood. Extrinsic, from outside of the blood. So it's usually a ripped open vessel. The collagen is those chemicals will begin the clotting process. Intrinsic begins from chemicals that are already within the blood, but both of them converge and it's the same clotting sequence after that. Just it can start from two different ways. At the end, you have this thing called thrombin, which is going to make fibrinogen convert to fibrin. And that will make the sticky net. The fibers will come together. Yeah, this is just showing you the platelets immediately causing a plug. Yeah. And indeed, and don't forget, you need vitamin K for clotting, and you need calcium. Without these things, and without the other proteins in your blood, like fibrinogen, you're not going to clot. You're going to have bleeding issues. Yep. So you can see the main chemical difference is fibrinogen to fibrin. That's the thing to focus on, and that's going to make these sticky fibers. And as I try to get through to you guys, I try to present is that you really live on the edge of if you clot too much, you die. You don't clot, you die. And so you always have, your body's always trying to prevent clots from happening when things are normal, right? And so the vessels themselves secrete this antithrombin, which prevents the thrombin from making fibrin, right? And also just movement. And so the key is when blood is stagnant, these chemicals build up and clots will form. So that's like DVT, deep vein thrombosis. When you sit for long periods of time, the back of your legs and some of these vessels, the blood will be stagnant and you can have clots forming, which can turn into emboli, travel, and get caught in your brain, your heart, your lungs. Yep. And it'd be called a pulmonary embolism, cerebral embolism, cardiac embolism, coronary embolism, when that clot blocks these vessels, this traveling clot, and then you're in big trouble. Yep. There's atherosclerosis, is hardening the arteries, and hemophilia, mostly in males because it's on the X chromosome, and it's a whole suite of clotting disorders. So you bruise easily. And my last slide. All right. And then make sure you understand blood groups. And do realize that there's many different markers on your blood cells. But a real important we found out are the A and the B. These are antigens. And get the terminology right. Antigens will be the surface proteins on these blood cells. And if you're type A, you've got A antigens. If you're type AB, you have both. If you're type O, you have neither. Okay, so that's the antigens. And your body makes antibodies for everything you don't have. So I'm type B blood. So I make anti-A antibodies. I don't make anti-B antibodies because that'd be dumb. I attack myself, right? That's the deal. And if you're type O, you have both anti-A and anti-B antibodies. And so once you know this, you can figure out who can donate to who if you just think about it. Yep. And so O's universal donor because it doesn't pick a fight with anybody. It's naked. It's got nothing on it. And most of you guys are O. Type AB, you can see here. Nobody wants that except other ABs because you give AB to a type B and the A is going to screw it up. You give the AB to a type A, the B is going to screw it up. You give AB to the person with O blood, it's going to be attacked by two different kinds of antibodies. So AB blood can get it from everybody. It's universal recipient. All right. Understand the RH factor. What's going on there? RH is just one more marker. And you're positive if you have the RH antigen on there. You're negative if you don't. I hope this was helpful. And again, you're coming in cold. This is way too fast, right? But hopefully for some of you, and you give me some feedback if listening to this, maybe listening to it twice after when you're almost ready to take the test is helpful. But I did it because I hope it helps you guys. All right. Have a good night.